right, hey Algebra 2 family. So we started off this day with these graphs. So given the following graphs, determine if each graph could represent the current spread of the COVID coronavirus here in the United States. Okay, so take a minute, pause the video, and then we're going to actually talk through how that corresponds. All right, so let's talk about it. So on this first one, we see that it's growing exponentially, right? And then on graph 2, we also see that it's an exponential function. Right, so we got exponential here, exponential here. On this third one, we see that this is a radical, okay? And then on this fourth one, that's a linear function. So if we're talking about linear functions, that would mean that one person would go directly to another person and infect them. And now this person is the only person who can infect one other people, or one other person. But that's not the case. That's not how COVID has spread, okay? On graph 3, this is saying that nobody had it, then one person had it, and only one person had it. And then 2 people had it, but they only infected 1.5 people. So there's no way that that's it either, right? Because we can't have half a person, right? So it's either going to be graph 1 or graph 2. Now the question is, all right, which one? Okay, so let's say that our y-axis is the number of people, and the x-axis is either the number of days or weeks, right? So we know that we know that coronavirus actually has spread very, very drastically. So this number seems kind of reasonable. We see over here that it's growing, but it's kind of growing slowly, okay? So we have reason to believe that graph 1 actually is the representation of the coronavirus. And this actually was the graph that was pulled from Google back in, I think it was March or April, okay? Because 44,183 people were infected at that point, okay? So looking at our next stuff, we're going to talk about growth and decay, okay? And so I think yesterday we talked a little bit about how if B was bigger than 1, then you had exponential growth. That means that you're going to go up, right? If B was in between 0 and 1, that means it was a fraction that produced a number that was in between 1 and 0, then it would be decay. And so on this one, we can see that it's growing, so we have an exponential graph. We have an exponential growth, okay? We can also tell by our B being bigger than 1, okay? Another thing to notice is for the end behavior, that means if we stand right here and we look to the right, so as x is approaching positive infinity, what's happening to our y values? They're going up. So we denote that by this. As x approaches positive infinity, y, or f of x, approaches positive infinity. Now the other way, if we're looking to the left, as x approaches negative infinity, then y is going to approach 0, or your asymptote. Remember, your asymptote is where it approaches but never touches. Okay? So again, this is how you denote your end behavior. End behavior is focusing on where the graph ends up. Okay? So looking at this next one, go ahead and pause the video. And I want you to think, is this growth or is this decay? Are you going up or are you going down? So looking at this one, we can see that it's 1/3. So that's B is less than 1, right? But it's bigger than 0. So we know that this is going to be decay. So let's focus our in behavior. So as x approaches positive infinity, as we're looking to the right, rough little stick figure. As we're looking to the right, what's happening to our y values? They're getting closer and closer to 0, which was the asymptote. if we look to the left, as x approaches negative infinity, what happens to our y values? They get bigger and bigger and bigger, right? So we always start at 0, 0, and then look at our in behavior. So for our horizontal translation, okay, and our function that we're dealing with is y equals ab raised to the x minus h plus k, where k deals with the vertical, so if it's going up or down, h deals with the side to side, or left or right. Okay? And then a is going to either stretch or compress. Okay, so a stretch is going to be a is bigger than 1. A compression is where it's a fraction in the front. Okay, you need to know the terms stretch and compress, because a lot of times they like to trick you up and say vertically stretch. Yeah? Or they say something crazy. Okay, so you need to make sure that you know what stretch and compress is. Okay? Now, if it's less than 0, then it's reflected across the x-axis. But notice how there's absolute values around a. That means the absolute value of whatever your a value is. Okay? So let's actually look at an example of this. So this one says, this graph is a transformation of the parent function 3 to the x, with a horizontal translation of 1 right and a vertical translation of 2 up. So they said 1 right because of that minus 1 and 2 up. And the reason why it's minus 1 is because in the original function, we've got a minus right here. Okay, so even though you're moving right, you've already got that negative included into your original equation. Okay? And so you can see that the asymptote is at 2. Which notice how your 2 is chilling out here, right? So this is your asymptote. Horizontal asymptote. Okay? If we're writing the in behavior, we're going to stand at 0, 0. We're going to go to the right. So as x approaches positive infinity, your y is going to positive infinity. As x approaches negative infinity, your y's are approaching 2. So we then introduce this concept of e. Okay, and e is kind of like pi, but instead e represents 2.7182, etc. Okay, so we can graph e to the x. Okay, and for your in behavior, again, it's the same thing almost every single time when it's growth. So if it's growing, this is going to be your in behavior, unless there's an asymptote that's added out here. Okay, it's the same every single time. So let's go ahead and look at this next one. It says one person is infected with the virus. Each day, the number of people infected with the virus triples. Okay, so we know right now off the bat, our base is 3. So when we write our function, our base is this guy. Okay? And we know that at 0 days, we got 1 person infected. So our initial value is going to be 1. So we've got 1 times 3 raised to the x. Okay? And if we actually graph that, we would get this table right here. So notice how the growth factor is 3, as in previous example. However, it's a real world context, so the domain will not be all real numbers, as time cannot be negative. So there's not going to be any numbers over here, because you can't have negative time. You start from day 0 and you keep going, right? Okay. So looking at this last piece, I want you to go ahead and take a moment and pause the video, and try to fill in the missing values. All right, so if we're trying to fill in the missing values, we can either use our graphing calculator or we can use our brains. I personally want to use my graphing calculator. So I'm going to type in 2 raised to the x power minus 2. And I'm going to go to second graph, and that's going to pull up my table. Okay, so obviously here are the numbers 2, 3, and then you want to fill everything else in. So 2 and 3, you've got 2, 3, you got 6, 0, you got -1. Alright, so 1, 0. You're trying to trick me on that one, but you didn't get me. And then -1 and -3. I've got -1.5 and -1.875. Okay? Then it says sketch the graph of the function and fill in the blanks for that nonsense. So I'm just going to hit graph to make my life a little bit easier. And again, rough sketch, doesn't matter. So 0, -1, 1, 0, 3, 6. And it's going to look like this. And it's going to have an asymptote at -2. Okay? So as I'm standing here and I look to the right. As x approaches positive infinity, my y values go up to positive infinity. As x goes to the left, which is negative infinity, my y's go to -2. Okay? So you should be able to graph or sketch it and then do the in behavior. Okay, so it says circle the correct answer for each equation and explain why. Consider this. Which of the following must be true for the parameter a? So we know that it's got to be growth, right? So growth is represented by a is bigger than 1. Which of the following must be true for the parameter c? Well, c can't be 0. C can be less than 0. C can't be greater than 0. Okay? The parent function is shown in the light gray on the graph. Graph the transform function on the same Cartesian, coordinate grid and describe the transformations. Okay, so the parent function is 2 to the x, and then we've got this function right here. So again, because I'm lazy, because I don't want to have to do extra, because I want to use my resources, whatever you want to say, 2 raised to the x minus 2 minus 6. I'm going to go in here and I'm going to hit graph. And I see that there is a vertical or a horizontal asymptote at -6. And then it just starts going this way. And it goes in between 4 and 5 and goes up. Sorry, that's a little rough. Okay, so I know that it moved 2 units to the right because of this 2 right here, and 6 units down. Okay, and then the last few. So again, I'm going to plug this into my calculator, and hopefully I won't run out of time. E raised to the x power plus 1. I'm going to go to table, and this has 1.0498, 1.3679, 02, 3.7183, 8.389, and 21.086. And then graph the function and determine the end behavior. So I'm just going to graph it really quickly. 1, 3, 2, 8, -1, 1, 3. Okay, so as x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y is approaching 1. Boom. If you have any other questions, just contact your teacher or you can reach out to me. Have a great day.